So the idea of composition we have here is FOG of x. And that means f composed with g. And we write that as f of g of x, f parentheses g of x close parentheses. What we're really doing here is we're substituting g of x into my function, into x in my original outside function f. And the resulting domain really depends on g. Whatever domain of g results in a number that satisfies f is going to be in the domain of this resulting function. So let's take a couple of examples of composition of functions. So here we have f of x is x squared and g of x is the square root of x minus 2, and we're asked to find FOG of x and its domain. So again, let's list the domain of the original functions. The domain of x squared is all reals, negative infinity to infinity, and the domain of the square root of x minus 2, where you can't square root negative numbers, so that's going to be 2 to infinity. Because anything below 2, if we plug it in here, we get a negative number. So 2 to infinity, including 2. That's the domain of g of x. So FOG of x, what that means is f of g of x. And f of g of x means I plug g in to x in my original f. In other words, if we take it stepwise, this means f of, what's g of x? Root x minus 2. So I'm plugging in the root of x minus 2 in for x into my function. And my function f says square whatever your input is, square it. So I have to square this. So f of root x minus 2 is going to give me the root of x minus 2 all squared. Because that's what f of x is doing. It's squaring the input. And so we know that if we square square root, we end up with undoing that square root. So my resulting function, FOG of x, is going to be simply x minus 2, once I simplify it. So the key question here is, what is this domain? Well, the domain is whatever is in g of x that will go into f of x. Now g of x has a restriction from 2 to infinity. F of x has no restrictions. F of x, you can put anything into it. But we're restricted by g of x. The domain of g of x is 2 to infinity. And because f of x can take any number, the output doesn't matter of g of x, but it does matter that the input of g of x can only be 2 to infinity. So therefore, the resulting domain is 2 to infinity. Even though this function is simplified and looks like, oh, it's just x minus 2, all reals can go in there. We're restricted by, remember, our original input, our original inside function was the square root of x minus 2. So we're restricted by that domain. So whenever we do these operations on functions, you have to think of what two functions are we starting with and what were those domains, because that determines the resulting domain of our functions. Very important concept, and you think of that in manufacturing. You think of it as a chain is as good as its weakest link. You have to think of where these things are coming from in application.